All right, let's get started. Lesson 2, using oxidation numbers. Now, we have learned in Lesson 1 how to assign oxidation numbers to elements in a compound or single elements by themselves. We can now use oxidation numbers to determine if a substance is being oxidized or reduced during a chemical reaction. So how do we do this? Well, first of all, we must understand three important things here. First of all, a redox reaction only occurs when there is a change in the oxidation number. So if you look at an element in its when it's a reactant, and then look at the element when it's a product, and you notice that the oxidation number has changed for that element during the reaction, then a redox reaction has occurred. All right? An element has been oxidized and an element has been reduced. All right? Now, oxidation occurs when there is an increase in oxidation number of an element. Reduction occurs when there is a decrease in the oxidation state of an element. So what this means then is that if you had, going back to our lesson 1 where we saw that magnesium changed its oxidation number, it went from 0, essentially, because it's an element, to a +2. So what we're saying here is that there's been essentially an increase in the oxidation state. And if there's an increase in the oxidation state, the element has been oxidized. All right, so oxidation has occurred here with magnesium. Oxygen, in our same problem, O2, went to oxide, -2 charge. Well, because oxygen's original oxidation number is 0 because it's in its elemental state, it goes from a 0 to a 2, -2. So the oxidation state has decreased. Therefore, oxygen has been reduced, or reduction has occurred here. All right? So that's kind of how we can determine if oxidation reduction has occurred. So we're going to actually practice this now. But to make this any sense, we have to be able to assign oxidation numbers, or it just won't work, okay? So let's take a look at this first example. Oxygen is in its pure form, so it must have a 0 oxidation number. Strontium is in its elemental form, so it also has a 0 oxidation number. Now let's look at the product. Oxygen would be a -2 oxidation number, and strontium would be a +2 oxidation number. So there's been a change in oxidation numbers. Therefore, a redox reaction has indeed occurred here. Oxygen is going from 0 to -2. There's a reduction in charge. Therefore, it's being reduced. We'll just say R for reduced. Strontium, on the other hand, is going from 0 to +2. It's increased its oxidation number, so it's being oxidized. We use O for oxidized to make this short and fast, okay? So there's number 1. Let's look at number 2. Bromine, elemental form, must be 0. Cesium is also in its elemental form at 0. Bromine is a -1 oxidation number. Cesium is a +1 oxidation number. So indeed, there's been a change. It's been an oxidation reduction reaction. Bromine, a decrease, so therefore it's been reduced. Cesium, there's an increase in its oxidation number, so it's been oxidized. All right. All right, now let's look at the last one here. Oxygen, 0, element. Iron, 0, it's an element. This should be a 2 and a 3 subscript. So oxygen should have a -2 oxidation number, and iron should have a +3 oxidation number. Okay, so if you remember, we'll look at that really quick. Should have a 0 overall. Oxygen is always a -2 oxidation number unless it's a peroxide, and this is not. So therefore, we have 6 negative charges, -2 times 3. Therefore, iron must be a +3 oxidation number to get the 3 times 2, +6 to get a 0. Okay? Just as a refresher there. So there has been a change in oxidation number. So oxygen looks like it's gaining electrons. It's going from 0 to -2, so it gains. There's a decrease in its number, so therefore it's being reduced. And iron is losing electrons. It's going from 0 to +3, so it's being oxidized, increase in oxidation number. All right, so there's 3 examples. Let's do some more here. Doing well. All right, so let's, a little bit more complex here. Chlorine, I think, is obvious. It's 0. It's in its elemental form. Bromine is a -1. Sodium is a +1. Our products, we have 0 for bromine in the elemental state. Chlorine is a -1, and sodium is a +1. All right, has there been a change? Absolutely. Chlorine certainly has changed. It's gone from 0 to -1, so it has been reduced. Sodium, notice sodium has not changed. So sodium actually is not participating in this reaction at all. But bromine is changing. It's going from -1 to 0. So it's actually being oxidized. It's losing electrons. All right, let's go to number 5. Sodium, 0, elemental state. Oxygen, -2. Hydrogen is a +1. Hydrogen over here is going to be 0 in its elemental state. Let's see here. Oxygen, well, sodium is definitely a +1. Oxygen is a -2. That means hydrogen has to be a +1. Okay, so there's been a change. Sodium looks like has lost an electron, being oxidized because it's an increased in oxidation number. Hydrogen hasn't changed. It's a +1 and a +1. Oh, actually, it did change right here. Never mind. So hydrogen went from 1 to 0. Aha. So it's actually gained electrons and been reduced. It's oxygen that hasn't changed in this particular problem. It's -2 and a -2. Okay? Awesome. Let's look at our next one here. Carbon must be 0. Oxygen is -2. Hydrogen is a +1. Well, what's sulfur? Well, it needs to be 0. We got -2 times 4 is a -8. +1 times 2 is a +2. That means sulfur needs to be a +6 in order to get us a 0 then. So it has a +6 oxidation state or number. All right. Okay, we got 3 products now. Let's look at oxygen here. That's -2. Hydrogen is a +1. -2 on the oxygen. That means sulfur's got to be a +4. Oxygen -2. And carbon is a +4 as well. Okay, I went through that fast. Let's see. Carbon's changing. It's increasing in oxidation number, so it's losing electrons. It means it's being oxidized. Hydrogen. What about hydrogen? Well, we got a +1 and a +1. Hydrogen looks like it's doing nothing. Sulfur is definitely doing something. It's going from a +6 to a +4. So it's actually gaining electrons. It's reducing in charge, so it's being reduction has occurred. And oxygen looks like it's doing nothing as well. It's -2, -2, negative 2, negative 2. So oxygen is doing nothing. So here carbon is being oxidized and sulfur is being reduced. All right. All right, let's do one more, okay? Are we having fun yet? Okay, so let's assign some oxidation numbers here. This is easy, -1 for the chlorine, +1 for the hydrogen. Oxygen here is going to be -2 because it's not a peroxide. Potassium is always +1. So if I need a 0, so -2, that's a -8 +1. So that means the manganese must be a +7 in order to get a 0. All right, so there's that. Got that down. All right, so what about our product here? Okay, chlorine is going to be a -1. That makes that manganese a +2. This is an element, so it's 0. 1 or -2, +1, -1, and a +1. Okay? So there, we've assigned oxidation numbers. Now, what's changed? Potassium, not changed. Manganese, definitely changed. Gone from a +7 to a +2. So, it's definitely gained electrons. So it's been reduced. Oxygen. Oxygen has not changed. Hydrogen has not changed. Chlorine has changed. Chlorine went from a -1 to a 0, so it's an increase. Therefore, it's been oxidized. So manganese has been reduced, and chlorine has been oxidized in this particular reaction. All right, so there are some examples of how to assign oxidation numbers first, and then looking at the change in oxidation numbers from the reactants to the products will help us to determine which element is being reduced and which one is being oxidized. Okay, so that's a skill you need to be able to do. All right, so that is it for lesson 2 for this particular lecture video. Study your notes. Look over these practice example problems to get more familiar with it, but that is it for now.